All right, so I'm not there in person, as y'all know. I've been telling you, have not graded the test because I'm recording this after the first or second period's test. So obviously, I haven't graded second period, and again, obviously, I haven't recorded my fifth period test because we haven't taken the test yet. But I'll be there on Monday. I'll tell you guys the averages of the test, how everything went. Other than that, today we're just gonna be talking about the lesson. Hopefully, everybody has a paper, got a paper, because we're about to take notes. So let me just share my screen real quick. Okay, being shared, I believe. All right, let me see. Yep, there we go. All right, so for today's lesson, what we're going to be doing is nth roots and rational exponents. So the first part is pretty easy. So all we're doing is finding out what one squared is. So we're just making the list. And the way you do that is you go in your calculator. So on your calculator, you just put one, right? One. I know I do have expensive ones. You can do this also with the cheap ones. And then to put the exponent, you have to put the caret button, which is this button right here. So if you have this little button right here, you click on it, and then you press the exponent. So since our exponent is two, we're putting in the two. And then we just click on enter. And it gave us that one squared is equal to one. So we would do this for all of them. And when you do it for all of them, you get that one squared is equal to one. Two squared is equal to four. Three squared is equal to nine. Four squared is equal to 16. Five squared is equal to 25. Six squared is equal to 36. Seven squared is equal to 49. Eight squared is equal to 64. And then nine squared is equal to 81. Finally, 10 squared is equal to 100. So we're just gonna do the same thing with the cubes, but the only difference is instead of putting in a two, we're gonna be putting a three. So again, you put one, and then again, you click that caret button. So caret, and then put in a three, and press enter. And then it gives us that it's one. But we would do this for all of them. And for if you did this for one cubed, it would also give you one. For two cubed, it would give you eight. Three cubed, it would give you 27. Four cubed, it would give you 64. Five cubed, it would give you 125. Six cubed would give you 216. Seven cubed would give you 343. Eight cubed would give you 520. Oh, wait, my bad, not 520. It would give you 512. Nine cubed would give you 729. Then finally, 10 cubed would give you 1,000. So hopefully you guys had did this list, and if you didn't, you could just copy it off of me. But that if you did use a calculator, you would be able to know that that's how you do it. All right. Next thing we're gonna do is do the same thing, but we're gonna find out what our nth roots is, right? This is just definition. So x is the nth root of a real number. A of a if x to the power of n is equal to a. That tall-way definition went over your head. All you gotta worry about is something is a root of it. If you multiply it by itself, it gives you that number. So for example, over here, -2 and +2 or I mean -9 and +9 are square roots of 81. And the reason why is because -9 squared is equal to 81 and 9 squared is also equal to 81. And similar, but for the cube roots, it's going to be -2 is the cube root of -8 because -2 cubed is equal to -8. All right. So radical expressions, the nth root of a real number, a can be rewritten as a radical expression n root a. All you got to know about this is your n. This n thing, we call it an index. So whatever that small number is what we call our index. The And the actual house we call a radican, radical, I mean, a radicand actually. And then this A is your radical. I might have messed that up. I'm pretty sure it might be the other way around, but you don't really got to worry about those names that much. So over here, if there's no index, so like let's say you don't have any number right there, you are to assume that it is a two there, an invisible two. All right. So over here, so some examples of these will be, so you have, let me, hold on, give me a quick second. Let me move this up. Wait, give me a second. I don't know why it's so loose. All right. There we go. So, what you're gonna do is you're doing the same thing, but now you're just finding out what they are. So you could do this in two different ways. The first way is you could look at your list and see. So over here, okay, but first, since there's no index, you pretend there's a two right there. But the first thing you could do is look at where there's a 16. So the 16, where is it on your list? So if you scroll up, the 16 is only next to the four. So it's obviously going to be the square root of 16 is obviously going to be four. That's so you could just say four, but and then since we take the square root, it's going to be a plus or minus in the front. So that's the first way you could do it. The second way is you could just go to your calculator and go over here. You click second first, and then go to the x squared button, and then it's going to give you that radical, and then just put in the number that you want. So 81, and then press enter, and it gives us 9. Or remember, always put a plus or minus because it's going to be like that. All right, so if we do the same thing, we'll do the same thing with this one. So negative, then the square root of 49 will give us plus or minus 7, which is just going to be plus or minus 7. For 1, same thing, plus or minus the square root of 1, which is just 1. Cube root of 8, you do similar. To the way that you do it, you could do it using your list, or you could use your calculator, but the way you would do your calculator is you would first have to put the index, which is 3, and then click second, but instead of x squared this time, we're going to be clicking, let me look for it. Should be around here somewhere. It's not on here, unfortunately. Do not know why. I don't know why it isn't on there, but on your, what's it called? The cheat calculator will have it on there. But unfortunately, since it's not on this expensive one, I'm gonna just do it on the straight top of my head. So the cube root of 8, this one is just gonna be 2. And you don't have to put a plus or minus in front of it because your index is odd. Whenever your index is odd, you don't have to put a plus or minus. You only do it when your index is even. So we're gonna do the same thing for cube root of 125. That's just 5 if we use our list. Cube root of negative 27, that's just gonna be, cube root of 27 is 3. And then since there's a negative, keep it a negative. All right, for the cube root of 343, if you look at your list, it's gonna be a 7. And then since there's a negative, keep it a negative. For this one, again, since your cube, this one you have your index of 2. The way you do your letters is a little bit more trickier. The way you do it is you keep the number, you keep your variable how it is. So over here, x, leave it as an x, and then look at your index and see how many times it goes into the exponent. So how many times is 2 going to 2? That's going to be 1. So you have 1, and that's your answer. So again, index is 2. And then, okay, what's your variable? It's an x, so put an x. Now, how many times is 2 going to 6? It is 3, so put a 3. Over here, same thing, index, it doesn't have one, so put a 2. What's your variable? An x. And now, how many times is 2 going to 10? 5 times, so write that down. For 16, again, what's your variable? Or first, there's no index, so put a 2. What's your variable? X. How many times is 2 going to 16? 8 times, so it's x to 8. Over here, again, with this one, it works the same way when it's a cube root. So again, what's your variable? X. How many times is 3 going to 3? Once, so put 1. Again, over here, variable. How many times is 3 going to 6? Twice, so put a 2. Again, over here, your variable is an x. How many times is 3 going to 12? 4 times, so put a 4. Then again, x. How many times is 3 going to 21? 7. And that's your answer. Right, evaluating radicals, I feel like isn't that much difficult, or isn't that difficult to do. I think it's the next part is the most difficult of what we're doing today. It's the simplifying radicals. It's easier with numbers, harder with the variables. So when you're simplifying radicals, the way you do it is you look at what the biggest number on your perfect list, on your list, what's the biggest number that divides 50. So over here, look at your list. What's the biggest number that divides 50? Does 1 divide 50? Yes. Does 2 divide 50? Or does 4 divide 50? Yes. Does 9 divide 50? Yes. Does 16 divide, or 9 does not divide 50? Does 16 divide 50? No. Does 25 divide 50? Yes. Does 36? No. Does 49? No. And then these numbers are bigger, so you can't do those. So the biggest one we had was a 25. So what you're going to do is you're going to go back here and rewrite square root of 50 as 25 times something. So 25 times what gives you 50? 25 times 2. So you go 25 and 2. But what's the square root of 25? That's just plus or minus 5. And then the square root of 2, you leave how it is. And that right there is your answer. So again, we're just going to do the same thing, but with 45. And I recommend starting with the first number that's bigger than 45, because you obviously know it's not going to be that one. So 49 is not going to work. Does 36 divide 45? No. Does 25? No. Does 16? No. Does 9? Yes. 9 times what gives you 45? 9 times 5. So rewrite this as 9 times 5. And what's the square root of 9? That's just plus or minus 3. And then leave the square root of 5 there. And keep your equals. And you're done. So for 192, you're going to do the same thing. So look at whatever the biggest number is that divides 192, and then just go from there. Okay. So there's 8. So you just look at your list, look at which one's the biggest one that divides 192, and then see how many what times that number would be. So like for example, the biggest number that divides 192 is 64, and 64 times what gives you 192? 64 times 3. And now you just have to find it. So what's the cube root of 64? That's just going to give you plus or minus 8, and the cube root of 3, and that right there is your answer. For 80, you're going to do the same thing. So what's the biggest number that divides 80? It's going to be 16. 16 times 5. But what's the square root of 16? That's just going to be plus or minus 4, and then leave the square root of 5. That's how it is, and that's going to be your answer. All right, 700, same thing. Again, what's the biggest number that divides 700? It's obviously going to be 107. And what's the square root of 100 is plus or minus 10. And then the square root of 7. And that right there is your answer. 72, keep on going. The square root of 72, what's the biggest number that divides 72? It's going to be 36. 36 times what? 36 times 2. So what's 36 divided by 2? I mean, what's the square root of 36? That's just plus or minus 6. And then leave the square root of 2 how it was. All right. For 147, again, same thing. What's the biggest number that divides 147? And then rewrite 147 as that number times another number. So for 147, the biggest number that divides it is 49. So it's 49, and then 49 times 3 gives you 147. And the square root of 49 is just plus or minus 7. And then you have the square root of 3, and that right there is your answer. 243, we're just going to continue this. So what's the biggest perfect square that divides 243? It is 81, but it's 81 times what gives you 243? 81 times 3. What's the square root of 81? That's just plus or minus 9, square root of 3, and that right there is your answer. And you're done. And I think this is the second hardest thing that we're doing today. The hardest thing I want to say is what we're doing on the back. So on the back, or I guess with the cube roots, it's the same thing. So let's just continue it. What's the biggest perfect cube? So look over here. Biggest 30, what number divides 32? So start with a number smaller than 32. Does 27 divide 32? No. Does 8? Yes. 8 times what? 8 times 4. So this is just going to be cube root 8, cube root 4. The cube root of 8 is just 2. And then cube root 4. And that's going to be your answer. Again, we'll do the same thing. I'm going to do 2 more because it's going to be repetitive. Biggest perfect cube that goes in 108. Start with a number bigger than 108. It's not going to be that one. The 64 divided by 108? Yes. So 64 times 2. And what's the cube root of 64? Well, on the back, we said it was 4. So we're putting 4 cube root 2. And that's it. Your answer. 48, we're going to do the same thing. The biggest number that divides 48. 27 doesn't. Does 8 divide 48? Yes, it's 8 and 6. So, well, 8 times 6 gives you 48. So, 8. And then 6. What's the cube root of 8? That's going to be 2. And then cube root 6. Now, 250, last one. What's the biggest cube? So, sorry, number closer to 250. So, this one doesn't. 216 doesn't divide 250. 125 does. So, it's going to be like that. So, it's going to be cube root 125. But 125 times what gives you 250? That's 125 and 2. And then what's the cube root of 125? That's just 5. And then cube root 2, leave how it is. And that's it, and you're done. So this is what you're going to be doing. So now the hardest thing, we're going to go to the hardest thing. So before we go to the hardest thing, those some quick definitions. So the square roots are exponents that must be multiples of 2. All right. And then cube roots are exponents must be multiples of 3. And the reason why or I guess this will be helpful will be in the next part. So here, we don't have no exponent here. So what we're going to put is an imaginary 2 right there. Okay. And then we treat it how we did on the backside. So what's my variable right here? It's an x. So leave it as an x. How many times is 2 going to 6? 3 times. So you get x3. Now I'll do the same thing with this one. What's your variable? Y. How many times does 2 go into 5? 2 times. But 2 times 2 gives you 4. And we will have 5 y's. So that's going to leave us left over with 1 y. So this would be square root of y like that. All right. It might be a little bit confusing. There's a better way, I think, that you could also do this. So another way you could do it, again, your exponent here is a 2. And then you could also do this. Rewrite your exponent like this, right? How many x's are there right here? There's 11 x's. So this one's going to be a little bit harder to do. What's this way? Here, I'll also do it. So just write down 11 x's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then we still have the 10 y's. So I'll put the y like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'll circle your copies of 2's. So here there's 2y, 2y, and 2y. Everything circled, but how many circles do I have for y? I have 1, 2, 3, 4, 5. So for y, it's going to have a 5. And I'll do the same thing for your x's. So it's 1, 2, 3, 4, 5, 1, 2, 3, 4. Oh, I forgot to multiply one more x. And then right here, that's 5 circles. So x has 5 circles. But we have one left over x, so we're just going to keep it here like this. And that's going to be your answer. All right, that might have been a little bit confusing, so we're going to do it again. So over here, again, how many x's do you have? Or I'll put the x's and the y's over here. So you have 1, 2, 3, 4 x's, and then 9 y's. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then get to circling your y. So you have 1, 2, 3, 4, and then so that's 4 y's. So you have y to the power 4. And then for x's, you have 1, 2, so 2 x's. And now for the square root of 32, you look back. Is 32 one of the numbers on the list? No. So you have to look at what the biggest number that divides 32 is. 36 doesn't. Does 25 divide 32? No. The 16? Yes. 16 times what gives you 32? 16 times 2. So right here, you'll have 16 times 2, but the square root of 16 is just 4. So put the 4 right here. And then what are you left over with? A 2 and a y. So this might be a little bit harder, more harder for you to see and do, or you could just go straight into this one. But whichever one helps you more is the way that we're gonna do it. All right, so here, again, square root. So if you do it this way, look, I'm gonna do it this way again. What's the square root of 9? It's just gonna be 3. Over here, how many times does 2, what's the variable first? X. How many times is 2 going to 3? Once. Y is your next variable. How many times is 2 going to 7? 3 times, because 2 plus 2 plus 2 is 6. But over here, are these numbers even or odd? All right, let me let it clear. No, because we said that x or 2 went into 3 one time. So you do 3 minus 2, which gives you an x. So over here in your square root, you're still left with an x. Then do the same thing. 2 times 3 is 6. So 7 minus 6 would give you 1. So you're still left with 1y. And that's how you're done. I'm gonna skip this one. Now I'm just gonna go straight into the cube root. So the cube root works again same. So how many times is 3 going to 5? Only once. So you just do your variable is x. And then how many your next variable is y. So how many times is 2 going or 3 going to 6? Twice. So put that down. So we're already done with this, but we're not done with this one. So over here, you said 3 went into 5 once. So what's 3 times 1 is 3. 5 minus 3 is 2. So you're still left with x2 here. And then since it is a cube root, make sure to keep this one a cube root. All right. So we'll do one more, and then I'll do the bottom two. The last part's super easy. So just this, we'll do this last one, and then I'll just skip the last one, and then you just be working on your worksheet. And then I was thinking of giving out a quiz today, but I'm just gonna have you guys do a quiz today, okay? So over here, same thing. How many times is 3 going to 8? Well, first your variable is x. 3 goes into 8 twice, so put a 2. What your next variable is a y. How many times is 3 going to 7? Twice again. But over here, 3 goes into 8 2 times, because 3 times 2 is 6. But what's 8 minus 6? 2. So you're still left with 2 x's. Over here again, 3 goes into 7 2 times, because 3 times 2 is 6. But 7 minus 6 is just 1. So you leave it like that. So again, we're just going to skip the last ones, but you are going to get something like that. This isn't be your hardest. And the reason why it's the hardest too is because it doesn't even tell you which way it's going to be. It's just going to tell you to simplify. And simplify can mean this, this, or even just across. So on the worksheet when it says simplify, I do apologize, but that's how it's going to be on the test too. So rational exponents. So its expressions with rational exponents can be rewritten as radicals using the following rules. A to the 1n, the nth root of a is just a over 1n is equal to n root a. And then again, a to the power of mn just means the same thing as this. So again, don't be over confused with this, but all you really got to do is, or all you got to worry about is the following. So you see how you have x to the power of 1/4? That means over here, the bottom number is what's going to be your root. So over here, and the bottom number is going to be your n, which is your whatever you're putting in the outside the house. So you put your house. This on the outside is always going inside the house. So x. And then this is going on the top of your house. So you put a 4. And then you're done. So that's all you're going to be doing. So again, I'm going to do it in different colors so it's more obvious to see. So first thing I will do is make my little house. Your radical. Now, blue is my m. Or I'm going to do, yeah, blue is my n. So when you put it in your n, technically there's supposed to be something like this with the blue having a 1 right there. But you don't have to worry about it when it's a 1. But your 2, that's your index. So you keep it 2 right there. And then over here, that's going to be inside the radical. So that's what we're going to keep on doing, okay? So again, make your radical, your house. Number is going inside of there. The bottom number of the fractions, what is on top of your radical, The top number of the fraction is what you're putting the whole exponent to. So again, over here, mistake. All right, this one over here, make your radical first. All right, green is what you're putting inside. Bottom number of the fraction is what you're putting on your index. And then top number is what you're putting the whole thing to the power 2 as. All right, so again, same thing. First thing, make your radical. Green is what you're putting in the inside. Bottom number of the fraction is what you're putting as your index. Top number of the fractions where you're putting the whole thing as an exponent to. All right, so again, same steps. Write down your radical. This number is what you're going to be putting inside the radical. The bottom part of the fractions, what's going to be your index. And the top number of the fractions, what you're putting as your exponent. All right, so super simple and quick. So again, we're just going to do the same thing over here. So just remember, but this time it's going to be reversed. The green is the number. The top number of the fraction was that outside one, so 2. And then the index was the bottom number of the fraction, so 2 over 5. So it's 3 to the power of 2 over 5. Again, same thing. Index is your number. Since there's no number on the outside over here, like this, pretend it's a 1. So that's the top number of the fraction. And that index is going to be the bottom number of the fraction. So like that. And this is what it's equal to. So again, over here, the number inside is what it's going to be. Blue is top number of fraction. And 2 is the bottom number of fraction. So I think you get the idea. So I'm just going to do one more. Or I'll just do all of them, I guess. So over here, there's no index, so pretend there's a 2. Green is the bottom number of the fraction. Since there's nothing being here, like this, pretend it's a 1. Then this right here is the bottom of the fraction. So again, over here, make it equals. Inside is what you're putting in there. On the top number of the fraction. And then your index is your radical. Then again, lastly, one more time, this doesn't have an index, so pretend it's a 2. Inside is what you're putting as your number. Exponent is what's on top of the fraction. Then the index is on the bottom of the fraction. And that's it, and you're done. So that's all for today's notes. So just work on the worksheet, and then you'll have nothing else, and I'll sign it off on Monday. So that is all, and hopefully you guys have a good time, and hopefully you're not making the sub have a bad time. All right, then I'll see y'all on Monday.